Okay, guys, so this question is pretty cool, straightforward, if you ask me, because I've seen questions like this which are a lot more harder. Now, if you see this type of question, I need you to make sure that you're not panicking. Lots of information once again, but we need to go through it bit by bit and make sure that we've got the most important pieces of information and work from what we already know. So here is a question. It says zinc chloride can also be prepared in the laboratory by the reaction between zinc and hydrogen chloride gas. Okay, it's not often that we get a solid and a gas reacting in exam questions, but they do, and this is one of those cases. An impure sample of zinc powder with a mass of 5.68 grams. Sorry. Now over here, it's impure. That's important. That means it's not 100% pure zinc. It's got some other stuff in it. We don't know what that impurities are, but we know that it does have impurities in it. Then it reacts with hydrochloric or hydrogen chloride gas until the reaction was complete. The zinc chloride produced had a mass of 10.7 grams. So this, has a mass of 10.7 grams. Interesting information. Calculate the percentage purity. So here we're looking at percentage, and we know that we've got to see basically how much of the pure sample out of the impure sample we have. So already you should be thinking about, I need to find the pure one, divide it by the impure one, times it by 100 to get my answer. And of course, there's another piece of information over here, because of course you have to read everything, and it says 3 significant figures. So the last thing you want to do is do the whole calculation correctly, and you do not write it to 3 significant figures. That really annoys me, and I'm sure that will annoy you even more, particularly because this is worth 4 marks in an exam. So let's do it then. What do we do first of all? The first thing we do is let's work out what we know. We know that we've got zinc chloride. The zinc chloride that was produced. Quite a thick pen there, isn't it? So let's just be a little bit more careful. And we've got a mass of 10.7 grams. So ZnCl2 equals 10.7 grams. And zinc chloride has a molecular mass. Let's work that out as well. So it has an MR of Zn is 65.4, chlorine is 35.5. There's 2 of them, so 71, 65.4 gives me 136.4. I've got these 2 now. So I've got my mass and I've got my MR. So my number of moles can be worked out from the following, right? So the mass is 0 point, what was it? 10.7 grams. Divide that by 136.4. That equals 0.0784. So this calculation I did in the calculator already. So there's your answer. Nice and easy. That's the first part. This is the number of moles of zinc chloride found. Now, let's look over here. It says that we want to find the sample of zinc. Now, zinc over here, if you look at my mouse, has a molar stoichiometric ratio of 1. Zinc chloride also has a stoichiometric ratio of 1. So there's a 1-to-1 ratio here between zinc and zinc chloride. So that means that if I've got 0.0784 moles of zinc chloride, I've also got the same for my zinc, which is going to be 0.0784. The last thing you do is you work out the mass of zinc. So the mass of zinc is, as you know, the number of moles multiplied by the molecular mass. And we want to find the mass of zinc, so don't get this one wrong. It's not zinc chloride this time. And the mass of zinc is just 65.4. Yeah? So we can do that. So let's write that down. So N equals 0.0784 multiplied by 65.4. And so the answer, therefore, is going to give us on the calculator a mass of 5.13 grams. 5.13 grams. Now, remember I said to you earlier on, that is the pure sample that we just found of zinc. We want to find how much of zinc is in our impure sample. So if this is my pie chart, all right, we're saying basically that there's a percentage that is basically pure zinc, and the rest of it is impure. We don't know what it is. That's not important to us. But we know from the question that the impure version, as I said earlier on, was 5.68. So let's keep that. Let's scroll down a little bit and let's write that down. So percentage purity, the last part then, equals the pure divided by the impure, which is 5.13 grams. Divide that by 5.68 grams. Times that by 100 because we want to get a percentage. And our answer is 90.31%, blah, blah, blah. Now, we have to do the last part, which is 3 significant figures. Now, please don't forget that. So the overall answer, therefore, guys, to 3 significant figures, 1, 2, 3. So we look at this number over here, and the number after it is less than 5. So this one over here is less than 5. So we know that the answer is going to be 90.3%. And there you have it. Thank you for listening.